All right, here is page 3 of the review. It says you may use a calculator. So again, you can put this in to your calculator. Since a, or our leading coefficient here, is positive, it's going to be not reflected. So that's where this no comes from. It is growth. When you look at the number that is being raised to the exponent of x, if that number is 1 or greater, then you want to say that it is growth. If that number is between 0 and 1, like for instance if this were 1/3, then that would be decay. So you're actually looking at the number that is being raised to the exponent of x in order to decide growth or decay. So this one's definitely growth. As far as shifts, if there were a value behind this x, that would be the h. That's where the h always is. So since there is no value behind this h, it is not shifted left. I'm sorry, I think I said behind this h. Behind this x, that would be the h. So there is nothing behind here, so it is not shifted left or right, but this +1 at the end means it is shifted up 1. The asymptote. The asymptote from these equations could always be found back here. If there were nothing back here, for instance, if this was 2dx, the asymptote would be at y equals 0. But since it's a positive 1, that is going to be the asymptote. You should also be able to easily see that from your graph, since you are using the graphing calculator on this one. The y-intercept, just like any other equation, that can be found by plugging in a 0 for the x. You can also find that on the table of your graph. And on the table on your calculator is where you would be able to find some of these other points to help you graph this accurately. Domain is going to be all reals. The range, this will not have the equal sign. What an asymptote is kind of like a boundary line. So this graph is never going to quite touch positive 1. It might be just barely over 1, but it will never touch it. So that will not have the equal sign underneath that. So again, you use some of those same buttons. You would use your second and graph button to get to the table, and that can help you, like I said, find points that you can accurately graph a problem like this on your test. All right, comparing one function to another. So we are, like it says here, identifying the shifts that occur and going from here to here. So first, when you look from here to here, as far as being reflected, they're both positive, so no, it's not reflected. Both positive, no. This one went from positive to negative, so yes, it's reflected. I'm going to give this little a value right out front. Positive here, this is also positive, so not reflected. Positive here, negative here, so yes, it's reflected. Positive here and positive here, so no, it's not reflected. Okay, and I'm going to skip over and do this column next so it's easier. So remember, the wider, narrower, or the same also comes from that same a value that we were looking at to see if something was reflected. So if we look at here, this had an a value of 1, and this has a 2. So remember, values here, absolute value of this, if it's greater than 1, that's going to make the graph narrow. This one stayed the same, coefficient here of 1, coefficient of 1, so that's the same. Coefficient of 1, this technically is a coefficient of negative 1, so the negative makes it reflect, but as far as being wider, narrower, or the same, it's the same. So you're looking at the absolute value. Absolute value of positive 1 is 1. The absolute value of negative 1 is also 1. So besides this being negative, they both have a coefficient of 1. On this one, the coefficient here is a 1, the coefficient here is a 1/2. So when you have an a value that is between 0 and 1, 1/2, that is going to make it wider. Okay, and then back to here, shifts. Remember on this, we're looking at what happens from f of x to g of x. So this is just x squared. So that's the parent graph. So on this one, we look at, again, our h value is right here. H is actually negative 1, so that means left 1. And then the k value is negative 5, so that's down 5. From this one, the x squared is the same on both of them. I'm looking at the difference in this plus 5, which would be 5 above. The graph would be shifted up 5. This one's graph would be shifted down 2. So the difference between up 5 and down 2 from this that was above 5 to 2 below would actually be down 7. So be careful on that one. That one might have tripped you up. On this one, we can see that this x value, we have an h in here. And h lies. This looks like negative 4, which might make you think left, but it's actually right 4. On this one, it went from a positive 3. Okay, so remember, this is the h value. A positive 3 is actually going to mean that this one is shifted left 3. This one, the h value, is actually 7, so this would be right 7. So the difference in left 3 and right 7, from left 3 to right 7, is actually going to be right 10. So try to visualize how that would look on a graph. And then as far as the vertical shift, okay, there was nothing here, and this one has a positive 1, so it makes it up 1. From this one, there is nothing up here with the x. H value would be up here in exponential form, and there is nothing, so it's not being shifted horizontally or left and right. But it goes from nothing back here to a plus 3, so that's going to make it up 3. So, and this is where I was talking about right here. So if there was an h value, it would be right behind here. So this one does not have, this does. Remember, h lies, so this is actually a negative 9 h value, which means left 9. And then this one was shifted up 5. And this one is shifted up 6. So from up 5 to up 6 would be up 1. So some of those can be a little bit trickier. You just have to be very careful, persevere, think when you're on the test tomorrow. Part 4, and this applies to the back as well, but we'll just do this part and then make a separate video for the 4th page. We are labeling, in this case, each equation as linear, quadratic, absolute value, exponential growth, or exponential decay. So, you know, linear is going to always be in the form of y equals mx plus b. Your exponent on your variables will always be a 1. So that's why this one is linear. Quadratic, your variable on your x is going to be a 2. So it's going to be a second degree. So that's why this one will be x squared. This one, if you FOILed it out, that would give you an x squared. So again, that's going to be an x of 2 on your x variable. Absolute value, of course, has the absolute value marks on it in an equation, so that should be pretty straightforward. And then between exponential growth or exponential decay, those are going to have a variable as an exponent, which both of these do. And then remember, you look at what is being raised to that exponent. You look at the base right here to decide whether it's growth or decay. When it is between 0 and 1, that, like this 1/3, is going to be decay. When that value is greater than 1, that is when you're going to see exponential growth. And that's it for that page.